Hello, this is Mr. Rasmussen with Algebra 1 and lesson 113. In this lesson, we look at two different aspects. One is a direct relation or variation, and the other is an inverse. So first of all, a direct variation or relationship is where if one part goes up, the other part also goes up. If one part goes down, the other one goes down. They are directly related in how they move. Let's jump straight into example number 1. In example number 1, it says the mass of a substance varies directly as the volume of a substance. So you have mass, okay, and then volume. Mass is how much is there, volume is how much space it takes. So it says if the mass of 2 liters of a substance is 10 kilograms, what will the volume of the 35 kilograms of a substance be? Okay, so there's two ways to do this problem. One is to set it up into a two-step problem here, and I'll show you that first. So in a direct relation, we'll put mass is equal to volume, and then they put a lowercase k here as kind of our constant, okay? So in the first way to do this is we solve and we find out what our conversion factor is, or our constant there, our k. So let's put these in here. Our first mass is 10 kilograms, and then we'll put in our variable, the k. And then our first volume is 2 liters. So it goes like that. And then we want to solve for k, so we divide by 2, and we find out that k is equal to 5. Okay, and that's like our conversion factor. Once we find that out, then we're going to place that back into the original equation. So m is equal to 5 times the volume. And that's how this one's set up in relation to the first part. So if we look at the second part, what do we know? Well, it says, what will the volume be if we have 35 kilograms? The 35 kilograms is the mass. So we put in 35 over here is equal to 5 times the volume. And so then we solve for the volume or divide both sides by 5. So we'll see that the answer, the new volume, is 7. All right, that's doing it in 2 steps. First, you solve for your constant, and then secondly, you use your constant to solve for the unknown that you're trying to get as an answer to your problem. The other way to do it is to set it up as ratios. We can do the mass of 1 over the volume of 1 is equal to the mass of the second over the volume of the second. Okay? And notice how it's just, this is directly relation, so the m's stay on top, the v's for mass and volume, it stays consistent. And let's see if this works here. Okay, so then we plug in some values. So it means our first mass is 10, our first volume is 2, is equal to our second mass is 35, and then on the bottom here, we don't know our second volume. So we'd simply plug in all the values, and then we would solve. Looks like my volume has to come up to the top, so I'm going to cross those two. Get that one up here, this one over here, and then cross multiply here to get the 2 up there. So we have 35 times 2 divided by 10. And you can see, yes, that gives us the same answer of V2 is equal to 7. So there's 2 ways to do it. One is through the 2 steps and find your constant. The second is to set it up through ratios. Okay, let's take a look at example 2. Once again, it says that they're directly proportioned. So we're looking at, they put a D and a T as the 2 parts. So let's read through this. The distance traversed by a car traveling at a constant speed is directly proportional to the time spent traveling. If the car goes 75 kilometers in 5 hours, how far will it go in 7 hours? So we've got time in hours, and then we've got distance in the kilometers. So the first way is to set up and find out what your constant or your conversion factor is. So let's do it that way. Our first distance is 75, and then our first time is 5 hours. So if we divide both sides by 5, it looks like our constant is 15. All right, plug that back in. D is equal to 15 times our time. Our second part there, we're told 7 hours. So we have 15 times 7. We don't know the distance, that's what we're trying to solve for. So 15 times 7, and we get an answer of 105 kilometers. Let's do it the other way, just to see. It's a direct relation, so we're trying to solve for D, so we'll put the D's on the top. So D1 and time 1 is equal to D2 and time 2. All right, you can see direct proportion, we keep the same things on the same levels. All right, our first distance is 75. Our first time is 5. Our second distance is what we're trying to solve for. Our second time is 7. So if we set this up here, it looks like we cross multiply 75 times 7 divided by 5. Let's try that. 75 times 7 divided by 5 equals, and yes, we get the same answer of 105 kilometers. Okay, moving on here. Now we have inverse proportion or variation. What that means is if one goes up, the other one is going to go down. They're inversely or oppositely proportioned. Okay, and the way we set that up in the two-step problem is where if we use the T's and the D's, the D is equal to, we put our constant in, but then we put the other one inside the denominator. We're going to flip it there down and make it a fraction out of it. So let's look at example 4. Under certain conditions, the pressure of a perfect gas varies inversely as the volume. So we got pressure and volume. Let's erase this out here. And okay, when the pressure of a gas is 7, so let's do pressure is equal to our constant times our volume like that. When the pressure of a gas is 7 pascals, the volume is 75 liters. So let's put those values in. We're going to put 7 is equal to our constant, and then our volume is 75. Okay, so let's find out what that's going to be. Cross multiplication looks like 7 times 75. And so it looks like our constant is 525. So let's put that back in. So pressure is equal to 525 over our volume. Now that we got our relationship there, we can solve for other values. What would the volume be if the pressure is increased to 15 pascals? Well, let's put a 15 in here. So we need to cross multiply to get the one we're solving for into the numerator. So that puts the V up here and the 15 down here. We have 525 divided by 15, and we get an answer of 35. And it is a volume, so 35 liters. And you see how we do that there. All right, now you may ask, that's a two-step problem. How can I do it in the one step, the proportions and the ratios? And I'll show you. In this case, we're going to have the pressure 1 over the volume 1. Okay. However, since it's inversely proportioned, the second pressure gets to the bottom, it flips, and the volume goes to the top. So I think it works that way. Let's find out. If not, we'll then we'll adjust it. Okay, let's flip that second equation there. Let's try it. Okay, so our first, we're trying to find the second volume, so there's that one. Our first pressure is 7. Our first volume is 75. Our second pressure, it was increased to 15. So we're going to get cross multiply, that goes up top there, 7 times 15 divided by 75, and that gives us 1.4. So that did not work. All right, let's try this again. I think I set it up wrong. Oh, I know what it is. Okay, let's try this again. Back to the drawing board here. All right, don't do it that way. It is pressure 1 over pressure 2, okay, equals 2, and then we got to flip their volumes. We'll do volume 2 over volume 1. All right, let's try that. Okay, trying to find our volume 2. So our first pressure was 7. Our second pressure increased to 15. For the volume, our first volume is 75. We're trying to find our second volume. So now we cross multiply. Okay, 7 times 75, 7 times 75, and then divide by 15 equals 35. All right, and we get the right answer there. Okay, let's look at example 5. It says to travel a fixed distance, the rate is inversely proportional to the time required. When the rate is 60 kilometers, so we're working with the distance is a fixed distance, the rate is inversely proportional to the time required. Okay, the rate is 60 kilometers per hour and the time is 4 hours. And that makes sense. If you go faster, it'll take you less time. What would the time required be the same distance if the rate were increased to 80 kilometers per hour? So let's look at how to do that here. First in the two-step problem. So we've got distance is equal to our constant and then inversely proportioned to our time there. All right, our first distance is 60 kilometers and then our first time is 4 hours. So if we do that there, we divide our 60 by 4. I'm sorry, we multiply our 60 times 4 and we get a constant of 240. All right, if we put that back in, distance equals 240 divided by our time. We now have our conversion factor there, and it's inversely proportional, so you see the fraction. What is we want to find our second distance is 80 kilometers. Okay, so 80 is here, and then we want to find our time. So actually cross multiply on those. T goes up there, bring the 80 down here. So 240 divided by 80, and we get 2 hours. So even though, let's see here, 60 kilometers per hour. Nope, I did that wrong. I read the calculator wrong. 3 hours. Couldn't see it there correctly. All right, so our time is 3 hours, and think that was right. You're like twice as fast, and you didn't go twice as fast. All right, so 3 hours there. You can see we found our constant. Let's do that in the proportions there. Distance 1 over distance 2 is equal to time 2 over time 1. Remember, we have to flip it. Question is if we do that up here, can we do that? Yeah, we can. Look, if we go back up here, we can rewrite this equation as m1 over m2 equals v1 over v2. That might be a better way to remember it there, and you'll get the same answer because you're just cross multiplying these. Whereas this, same thing here, you take that same setup and you just flip. Instead of having the ones lined up on the top, you gotta flip it there because it's inversely proportioned, just like you have the fraction over here. Okay, let's do this same problem here. Our first distance is 60 kilometers. Our second distance, oh, that's wrong. No, it is right. Sorry. 60 kilometers as a distance, and then 80 kilometers is our distance there. Oh, I'm sorry, that's why I'm getting messed up. That's a rate. That's not a distance. That's a speed. So let's put R's in there. There we go. Let's change those. All right, the rate is 60 kilometers per hour, not a distance. Okay, the rate increases. Okay, so put R's in there instead of D's because, yeah. All right, so if the rate is 60, first one is 60, second one is 80. Our first time is 4 hours, and we're trying to solve for our second time right here. So we cross multiply, our 4 comes up. So basically 60 times 4, you see that's really set up the same way. 60 times 4, 240 divided by 80. It's doing the same thing, it's just doing it without finding the constant. Alright, so 60 divided by 80, we get 3 hours. Okay, let's move on to our practice problems. Go ahead and pause the video and try these yourself, and then check your work with my work. Alright, practice problem A. The mass of a substance varies directly with the volume of a substance. If the mass, okay, so we got mass and volume again. So mass equals constant, and there's our volume. Okay, we see multiply because direct relation. If the mass is 30 and the volume is 6 liters, our constant looks like is going to be 5. So if we plug that back in there, put 5 in there, then our new volume is 65. So 5 times 65 equals what the mass, oh, it says find the volume of, okay. All right, do that one again. Find the volume of 65 kilograms, which is the mass. So 65 goes here, equals our 5 times our volume. So divide by 5, divide by 5. Looks like 65 divided by 5 equals 13. All right, so our new volume is 13, and that is going to be liters. Let's check that with the book here. All right, and that is correct. All right, let's do it the other way as well. We'd have mass 1, mass 2, oh, yeah, I keep doing, yep, 2 over volume 1 and volume 2. There we go. So our first mass is 30, our second mass is 65, our first volume is 6, and then we're trying to solve for our second volume. So these get flipped. Our V2 comes up here, our 30 comes down here, our 65 comes up here. So we have 6 times 65 divided by 30. 6 times 65 divided by 30 equals, and 13 is our answer. Okay, looking at our second one there, it also varies directly. And so I like doing it well, we'll do it both ways. All right, under certain conditions, the pressure of the gas varies directly as the temperature. When the pressure is 100 or 1,200 pascals, the temperature is 300 Kelvin. What is the temperature when the pressure is 30 pascals? So we can see the pressure is going down, therefore the temperature is also going to down because it's directly related. All right, we got pressure is equal to our constant times our temperature. Our first pressure is 1200. Let's find out what our constant is, and temperature is 30. So basically 1200 divided by 3, we get 4 as our constant. Okay, so if we put 4 in there, then our new pressure is 300 is equal to 4 times our temperature. So divide by 4, basically 300 divided by 4, and we're getting 75 kelvins as a temperature. Let's set it up the other way. On the other way, we're going to have our first pressure of 1200 over top our second pressure of 300 is equal to our first temperature of 300 Kelvin, and we're trying to find the second temperature. Cross multiply, our T comes up here, our 1200 is going to go down there, our 300 is going to come up there. So basically 300 times 300 divided by 1200, and we get 75 kelvins for a temperature. All right, looking at practice problem C. Under certain conditions, the pressure of an ideal gas varies inversely as the volume. So as the pressure goes up, it's going to shrink it and the volume is going to go down. When the pressure of the gas is 9 pascals, so let's put this in here. pressure is 9 equals to our constant, and then our volume is 100. Now this is inversely proportional, so there is my fraction. Let's find out what my constant is. Looks like I cross multiply and my constant is going to be 900. So if I put that back in here, 900, let's find out what they give us to solve for. What would the volume be if the pressure is increased to 20 pascals? So 20 pascals, pressure is going up, that means the volume is going to go down. It's going to be less than 100. Our volume 2 is what we're trying to solve for. So cross multiplication here, basically we have 900 divided by 2, or divided by 20, and it looks like we get an answer of 45 liters for our volume. So it went down from 100 to 45 because the pressure went up. It's squeezing it into a smaller space. All right, let's look at that in the ratios. Our first pressure is 9. Our second pressure is 20. Then we got to flip, right? Our volumes. Our first volume is going to go on the bottom, which is 100, and then we're solving for our second volume like that. So cross multiplication, 900 basically divided by 20, and we get the same answer. Okay, if you need some help on that, feel free to reach out to me. Have a great day.